In this video, I'm going to be going over how to solve for delta G given a reaction. So if we are met with an equilibrium reaction, A goes to B, and we are given the following information that K is equal to 5, the concentration of A at this given moment is 2 molar. The concentration of B in this moment is 4 molar, and the temperature is 25 degrees Celsius. How can we solve for delta G? So delta G is equal to R times T times ln, which is the natural log, of Q divided by K. So going through each one of these variables, R is our gas constant, which is 8.314 joules per mole times Kelvin. Temperature will be the temperature of our reaction in Kelvin. Natural log will simply be put into our calculator, and Q and K are both products over reactants. However, for Q, this is right now, and for K, this is at equilibrium. So plugging in what we know, we can start to solve for delta G. So delta G is going to equal 8.314 joules per mole times Kelvin. The temperature is 25 degrees Celsius. However, to convert this to Kelvin, we need to add 273 to get a temperature value of 298 Kelvin. Multiplied by the natural log of Q over K. Now we know that K is equal to 5. So we can plug in K. And all we need to do is solve for Q. We know that Q is equal to the products over reactants at this given moment. And right now, the concentration of B, our product, is 4 molar, and A is 2 molar. So Q is equal to 2. Now that we have filled in all of our variables, we can pick up our calculator and solve for what delta G will be. So when I plug this in, 8.314 times 298 Kelvin times the natural log of 2 divided by 5, I get negative 2,270.18. Now let's think about our units here. This whole term will be unitless. Q and K do not have a unit. So all we need to do is worry about the units. We're multiplying these two terms together. Joules divided by mole times Kelvin will cancel out our Kelvin, and we will simply left with joule per mole. So the delta G will be negative in this case. So we know this is a spontaneous reaction in the forward direction. So we know that at this given moment, A is going to proceed to B. That is because our Q value is less than our K value, Q is 2, and K equals 5. So Q needs to catch up to K. It wants to become equal to 5. So in order to do that, we will increase our value of Q. We will have to increase our products. So we should run this reaction in the forward direction. Now, delta G will confirm that because it is negative, meaning this is happening. We don't need to put in energy in order for A to proceed to B. It wants to happen. It is a spontaneous reaction. So this negative value of delta G confirms that this reaction will be spontaneous in the forward direction. So if we had got a delta G value that was positive, we would know that we would have to put in a positive amount of energy in order for A to proceed to B. So be careful when working with delta G to keep your signs correct, and make sure that you're using the correct units in order to get every unit to cancel out so you can get your answer in joules per mole.